question at hand is to solve dy dx given by 5x over 7y. Now to solve this, just first cross multiply. So we'll have 7y dy equals to 5x dx. Integrating both sides, we'll get the integral of 7y dy equals to the integral of 5x dx. This will give us 7y squared over 2 equals to 5x squared over 2 plus c. Then multiplying through by 2, we get, let's say this is c1, 7y squared, 5x squared plus 2c1. Then we can fix 2c1 to be c. So which implies y squared will be 5 over 7 x squared. Okay, let's say c is 2c1 over 7 and then plus c. Or you can say y equals to plus or minus square root of 5 over 7 x squared plus c. That gives the solution to the question given. And then 2, solve the nonlinear equation. Dy dx given by 6x power 5 minus 2x plus 1 divided by cos y plus e raised power y. So just like in the previous case, we cross multiply to separate the variables. So we'll have cos y plus e raised power y multiplied by dy equals to 6x power 5 minus 2x plus 1 dx. So I have successfully separated variables by that cross multiplication. Next, we integrate. So I'll have the integral of cos of y plus e raised power y dy equals to integral of x power 6x power 5 minus 2x plus 1 dx. Now, integration operator is linear, so we can supply integral to each of the terms. So integral of cos y dy, integral of e raised power y dy, integral of 6x power 5 dx, plus integral of minus 2x dx, plus integral of dx. This will give us sine of y plus e raised power y. Now this will give us x power 6. This will be minus x squared and then plus x. And then we add the constant of integration. So therefore we have sine of y plus e raised power y So this will be the final solution for that given problem. And next, number 3, solve y dy dx plus x y squared equals to x. Now we need to check whether this is a separable differential equation. So start by multiplying each term by dx. So we have y dy plus x y squared dx equals to dx times x. And then we have y dy equals to x dx minus x y squared dx. So I've taken this term to the right hand side. So next I'll have y dy, common here is x into 1 minus y squared, and then dx is also common. So for the right hand side to be a function of x alone, we divide through by 1 minus y squared. So divide through by 1 minus y squared, 1 minus y squared. So this term and this term cancels out. So we have y over 1 minus y squared dy equals to x dx. Now at this point, this is separable. So next to integrate both sides. That means we have integral of y over 1 minus y squared dy equals to the integral of x dx. Now left-hand side integral y over 1 minus y squared dy, we use integration by substitution. So let u to be 1 minus y squared. So which means du equals to negative 2y dy. So which means dy alone will be negative du over 2y. So this will be integral of y over u times negative du over 2y. So y and y cancels out. We'll have negative a half du over u. So which will give us negative a half ln of u. So this means that left-hand side integral, which is y over 1 minus y squared dy, is negative a half ln of 1 minus y squared. So negative a half ln of 1 minus y squared will be equals to integral of x dx is x squared over 2 plus, say, c1. So in multiplying through by 2, I'll have negative ln of 1 minus y squared equals to x squared plus 2c1. And then I can fix this 2c1 to be, say, c, so that we have, now this can be written as ln of 1 minus y squared power negative 1 equals to x squared plus c. So which is the same as ln of 1 over 1 minus y squared equals to x squared plus c. Now, exponentiating both sides, so we have 1 over y squared equals to e raised power x squared plus c, which we can write as e raised power x squared, e raised power c. If we say e raised power c, let's call it a constant a, then 1 over 1 minus y squared is equals to a e raised power x squared. So which is the same thing as saying a e raised power x squared into 1 minus y squared is equals to 1. Or you can say 1 minus y squared times e raised power x squared is equals to, say, k, where k is 1 over a. So this is the solution to a given differential equation. Now, number 2, example 3, solve 1 plus y squared x plus 1 plus x squared dy dx equals to 0. Now, solution for this, multiply by dx, so 1 plus y squared x dx plus 1 plus x squared dy equals to 0. Now, after that, we have, say, 1 plus y squared x dx equals to negative 1 plus x squared dy. So we can divide through by 1 plus y squared, divide through by 1 plus y squared. So this and this cancels out. X dx equals to negative dy. So we have negative 1 plus x squared over 1 plus y squared. And then again, you multiply this one by negative 1 over x plus 1, x squared plus 1. So this will be negative 1 plus x squared. So this and this cancels out, negative and negative cancels out. So we have 1 over 1 plus y squared dy equals to negative x 1 plus x squared dx. So next we integrate. So integrating, we'll have integral of 1 over 1 plus y squared, integral of negative x over 1 plus x squared dx. So by definition, this would be tan inverse of y equals to, now here we let u to be 1 plus x squared. So du will be 2x dx. So dx will be du over 2x. So this is the integral of now negative x over u times du over 2x. So x and x cancels out. So tan inverse of y equals to negative a half du over u, which will be negative a half ln of u plus c, but u is 1 plus x squared. So tan inverse of y equals to negative a half ln of 1 plus x squared, then plus c. So we can Write this one as tan inverse of y plus a half ln of 1 plus x squared equals to c. Now, loss of logarithms, this half ln of 1 plus x squared, the same as ln of square root of 1 plus x squared. So plus ln of square root 1 plus x squared, then equals to c. Or you can say tan inverse of y is the same as, so this c can be written as ln of, say, a constant a minus ln of square root of 1 plus x squared. So I've simply taken this term to the right-hand side and say c to be written as ln of a to be ln of c to be ln of a. So which means tan inverse of y is ln of a over square root of 1 plus x squared. Just applying the property that ln of a minus ln of b is ln of a over b. So if tan inverse of y is this, so this means y is tan of ln of a over square root of 1 plus x squared. And this will be the final solution. And then lastly, solve dy dx equals to 5y over 7x. We cross multiply and then get 7x dy equals to 5y dx, and then divide by 7x, divide by 7x. So this and this cancels out. So dy equals to 5y over 7x dx. And then you multiply by 1 over 5y, 1 over 5y. So we have 1 over 5y dy equals to 1 over 7x dx. Then integrate, so I have 1 over 5 dy over y equals to 1 over 7 dx over x. So this will give us 1 over 5 ln of y equals to 1 over 7 ln of x plus c. Let's call c1. Now we multiply through by, so this can be written as ln of y power 1 over 7, 1 over 5 equals to ln of x power 1 over 7 plus, let me write this one as ln of, say, c, where c1 has been written as ln of c. So ln of y power 1 over 5 equals to ln of, so loss of logarithms, this will be c x power 1 over 7. So this means y raised power 1 over 5 equals to c x raised power 1 over 7. Now you can make y the subject of the formula by raising 5 on both sides of this equation. So it will be c raised power 5, x raised power 5 over 7. And if we say a to be c power 5, then this implies y is a x raised power 5 over 7. So this becomes the solution.